Hi everyone! For today, we're going to go the other direction. Now we want to go from radians and convert to degrees. We're going to stick with this conversion factor here, but the way we set these problems up is a little bit different from the problems last time. So let's look at number 1. In number 1, we want to convert pi over 3 radians into degrees. So when we set this up, again, we want to make sure that our units are canceling so that we end up with degrees in our final answer. So when you set this up, don't forget, pi over 3 describes radians, and radians in this case is in our numerator. So in order to cancel radians in our numerator, we want to make sure that radians shows up in our denominator and degrees is in our numerator because that is what we want to end up with. All right. Now we can include the conversion factor here. We know that 180 degrees is equivalent to pi radian. So that's how we're going to set this up. So we want to make sure our units cancel. We want to make sure radian shows up once in our numerator and once in our denominator. Since that happens, they cancel. Excellent. But there's one other thing that we can cancel here. Notice that we have a pi in our numerator and a pi in our denominator. When you end up multiplying and simplifying, this becomes pi over pi, which is just 1. So we can cancel this out. This now turns into 1 times 180 in our numerator, so we get 180 degrees. And this turns into 3 times 1 in our denominator, which gives us 3. So finally, we want to simplify this. We get 180 degrees divided by 3. Now 3 is just a value. We just want to simplify it. We end up with 60 degrees. All right, let's look at number 2. Okay, now again, very similar setup. We have pi over 4 radians, and radians is in the numerator. So we're going to multiply by the same conversion factor, but this time again, radian must be in the denominator with degree in our numerator so that we get the right units canceling out. So we have 180 degrees here, pi in the denominator, and with radian here and pi here, these will cancel. So we end up with 180 degrees over 4. And when you simplify, we get 45 degrees. All right. Now, let's look at number 5. So for number 5, you're going to want to have a calculator handy. So let me go ahead and grab mine. Okay. So we want to convert 5 pi over 6 radians to degrees. So we're just going to set this up same as before. Radians here, So we know we want radians in the denominator, degrees in our numerator, and fill in the info. All right. So these radian labels will cancel. We have a pi in our numerator and a pi in our denominator. That will cancel as well. So now we can multiply across. And in this case, we end up getting 5 times 180 in our numerator. So 5 times 180 will give us 900 degrees over 6 times 1, which is 6. All right, so now we end up getting 900 degrees divided by 6. This will give us 150 degrees. So let's try number 4 together. Comparing 5 and 6 to the examples above, you probably notice that something is different. Maybe something is missing. Okay, you probably see that we are missing a pi in our angle measure. But that's all right. It's going to be the same process. You're just going to need a calculator a little bit more. So, again, we want to make sure radians cancel. So when we set this up, radian is in our denominator with degrees in our numerator. So what does this look like? We end up with pi in the denominator, 180 degrees in our numerator. And don't forget, 6 radians is technically over 1. Now, all we have to do here is multiply across. So, radians cancel. And we get 6 times 180, which is 1080 in our numerator. Over pi in our denominator. All right, this looks okay, but when we use degrees, we want to get rid of this pi symbol. So you're gonna put in your calculator, let's see if I could bring this here. So since we're working in degrees, you want to make sure your setting is in degree. And we want to take 1080 divided by pi. So the symbol here is this button. Oops. Okay. And that will give us approximately 343.7746770778. And so on. So let's say we want to round to the nearest tenth here. So we know that it's approximately 343.77 degrees, but I want to round to the nearest tenth. So we want only 1 decimal place. So we look to the number on the right of it. Since it's greater than 5, then we will round up. So this means our final answer is approximately 343.8 degrees.